the laws of logarithms here. So here are some of the basic laws of logarithms. So suppose that m, n, and b are positive real numbers. So again, this means that these are greater than 0, and the base, b, is not equal to 1, and r is any real number. Then here are the properties that we have. Now, some of these are not really properties that you really need to know, because if you look at the first one, log base b of 1 is 0. Well, that's the same as saying b to 0 is equal to 1. So I think you already knew that. All right, the next one, log base b of b is equal to 1. Well, that's the same as saying b to the 1 is equal to b, which you already knew. Log base b of b to the x is equal to x. Well, again, that's the same thing that you already knew, because you knew that that's the same as b to the x equal b to the x. All right. B to the power of log base b of x is equal to x. Remember, that's what I showed you as the previous property that we had. Now, this one is a new one that is sort of probably something that you will want to remember. All right. So then that one's actually not anything too spectacular. It just says log base b of m times n is equal to log base b of m plus log base b of n. So the one thing to remember is that there's one log on this side and there are two logs on the side with the adding. All right, so just remember that here. Now, this next rule you really don't need to memorize if you don't want to, because log base b of m over n is really log base b of m n to the negative 1 power. All right, and then this will be using the rule that I just told you about, log base b of m plus log base b of n to the negative 1 power. And then using the rule that is actually rule number 7 here, I can bring that negative 1 in front, so it's log base b of m minus log base b of n. So there, I just actually showed that here, so I don't actually need to memorize rule number 6. I could just write that as n to the negative first power every time if I wanted to. Now, that means that rule number 7 is actually fairly important, because I needed it to show that I could bring this exponent in front here. But if you think about this, though, like if I had, say, log base b of, say, m to the third power, right? That's log base b of m times m times m. But then if I use log rule number 5 over and over and over again, that's log base b of m plus log base b of m plus log base b of m, and then I added that together 3 times. So there, I just showed you that you could actually just not use the power rule if you really didn't want to use that power rule either. All right, but just remember, though, that in other words, you can bring the exponent down in front if you would like. All right, then if log base b of x is equal to log base b of y, then x is equal to y. And then the next one here, this one right here that I'm boxing in, that is actually the change of base formula that I already told you about as well. All right, so there you go. So those are the rules. So the only two new ones on this page really are Rule 5 and Rule 7. So just try not to get too upset about this if you can avoid doing that. But otherwise, just memorize all these rules for the rest of your life. All right, so now let's go ahead and use the laws of logarithms to evaluate each expression. So if you remember in the last section, what I would have done is I would set this equal to x, and then I would have said 3 to the x is 3 to the 7, and so x is equal to 7. That's fine. However, I know that just by looking at this, if I look at rule number 3 here, see, if the base of the log and the base of the exponential expression here are the same, then this is just equal to x. So really, I could also use rule number 7 to show this, and it's 7 log base 3 of 3, and log base 3 of 3 is 1, so that would be 7 times 1, which is 7. So there's lots of ways to go ahead and do this, but in either case, this value is 7. All right, so the same thing here. I set this equal to some x value, and so before I would have said this is 4 to the x is 64, and then I need to figure out this is 4 to what power is actually 64, so that would be 4 to the third power, so x is equal to 3. All right, but here if I use the properties of logs, I could rewrite the 64 as 4 to the third power, and then I know right away that since this number here and this are the same, this is automatically equal to 3. All right, so these are the same types of problems, it's just that they are just written in a different way. Like this, just a pretty much shortcut way to do these so that you don't have to write out the equation to solve this every time. So log base 5 of 125, that's log base 5 of 5 to the third power. So 5 and 5 are the same, so this is equal to 3. All right, I'm moving the chair here because it was getting a little bit uncomfortable to sit in this metal chair. So 3 to the power of log base 3 to the 5 power. So if this 3 and this 3 are the same, then remember that I can use rule number 4 to say this is just equal to 5. All right, so that was the rule that said b to the log base b of x is equal to x. All right, so hopefully you enjoyed that here. So let me actually, this ended up not being the most comfortable for me either, so I'm actually going to sit in a more comfortable chair at the moment. So let's try number, these aren't even numbered, it's a letter E. All right, E to the natural log of 10 power. So remember, natural log means log base E. So this is E to the log base E of 10. And then when these are the same, these bases are the same, both E in this case, then this is just equal to the 10. All right, so there we go. The next one, 10 to the power of log 13. Well, if you have just log 13, that's the common logarithm, so that's base 10. So 10 to the log base 10 of 13. So since these bases are the same, then that means that this is just going to be 13. So hopefully, again, you're enjoying this. So let's try another one. Log base 6 of 9 plus log base 6 of 24. All right, so this one is a little bit more difficult than some of them that we've had so far. But remember, though, that these are both the same base of 6. If these were not the same base, I would not be able to use the rules that I am talking about right now. So remember, just look here that on the rule I'm about to use, rule number 5, both sides have base b, base b, base b, all the same base. So otherwise you could use the change of base formula to write these all having the same base first, but I think that's a little bit outrageous, and I wouldn't do that if I didn't necessarily have to. So I'm going to use the rule number 5 here. So that's log base b of m plus log base b of n is log base b of m times n. So this is log base 6 of 9 plus log base 6 of 24. That's log base 6 of 9 times 24. And then 9 times 24, this is going to be, all right, so if I go ahead and do that, I get 216. So that's log base 6 of 216. And then 216 is actually 6 to the third power. So that's log base 6 of 6 to the third power. And now these bases are the same, so this is just equal to 3. All right, what a time to be alive. All right, so actually, I just realized that the chair that I'm sitting in now goes up to about the same height as the chair that I was sitting in before, but it's a nice, comfortable chair, not a bar stool that's not as comfortable here. So now let's go ahead and look at another example. So this is an example that has subtraction. All right, so we have the rule for subtraction: log base b of m minus log base b of n is log base b of m divided by n. All right, so the only difference here is that one of the problems had addition and one of them had subtraction. All right, G had addition, H had subtraction. But we're still looking at a situation where the base is still 3 or the same for each of these logarithms here. So log base 3 of 135 minus log base 3 of 45 is log base 3 of 135 divided by 45. So that is going to be log base 3 of 3. And since that's really 3 to the first power, that means that this is just going to be, well, that's just going to be 1. All right, so that is equal to 1. All right, so now I, negative 1/3 log base 3 of 27. So a way to do this would be to bring that exponent back up. So remember we had p log base b of x was log base b of x to the p power. So that means that negative 1/3 log base 3 of 27 is equal to log base 3 of x to the negative 1/3 power, but that would be 27 in this case. So 27 to the, 27 to the negative 1/3 power. So then that negative actually means, what am I going to do now? That means bring that to the denominator. All right, so that's log base 3 of 1 over 27 to the 1/3 power, and then 27 to the 1/3 power is 3, so it's log base 3 of 1/3. And then from here, there's lots of ways to do this, right? One way is log base 3 of 1/3 is 1/3 is 3 to negative 1, and so this is just negative 1. Or you could say this was log base 3 of 1 minus log base 3 of 3, and log base 3 of 1 is 0, and log base 3 of 3 is 1, and 0 minus 1 is negative 1. So again, I really don't care which logarithm rules that you use. Just make sure to use ones that you actually remember so that you can get the problem correct. Because there's always going to be more than one way to get to the correct answer using different rules. And that's why I said that you really don't have to memorize all of them. Just get used to using the rules that are most comfortable for you, and it will be fine, all right? All right, so natural log of the natural log of e to the 200 power. So I'm going to work from the inside out here. So this is actually one of those cases where I will use the power rule. All right, so the power rule to bring this exponent in front of the inside log. So natural log of e to the 200 natural log of e. Now, what I need you to remember now is that the natural log of e is log base e. So that's natural log of e to the 200 log base e of e. But log base e of e is 1. So this is natural log of e to the 200 times 1. So that's natural log of e to 200. So I can bring that 200 in front. So that's another exponent. So 200 natural log of e. But I just showed that natural log of e was equal to 1. So this is 200 times 1, which is 200. All right, so that is 200. So that's just actually a fancy way of writing 200. All right, let's try another example then on expanding and combining logarithmic expressions. So here is the first one here. Use the laws of logarithms to expand each expression. So that means that instead of just evaluating the expression now, I want to go ahead and write it out in the long form here. So I see that there's multiplication being done of log base b of m times n, which will be log base b of m plus log base b of n. So I have, you can see here, the x squared times the cube root of x minus 1. So I'll rewrite this as log base 2 of x squared plus log base 2 of the cube root of x minus 1. And then I will go ahead and make sure that besides making sure that you deal with the adding and subtracting, the only other thing that you really need to do is make sure that you bring the exponents in front. So this one here, the cube root of x minus 1 is actually an exponent hidden in disguise because it's really the x minus 1 to the 1/3 power. All right, so after I do that, I am going to just use the power rule for logarithms to bring the exponent in front of the logarithms. So if I do that here and here, I have 2 log base 2 of x plus 1/3 log 2 of x minus 1. And that's what I call expanding the logarithmic expression. All right, so hopefully you enjoyed that. So let me go ahead and do a couple more here in our last 5 to 10 minutes together here. So log, or natural log in this case, of 2x times the square root of x squared plus 1 over x plus 3. So here I have division. So I have natural log of m over n. So that's natural log of m minus natural log of n. So natural log of 2x times square root of x squared plus 1 minus natural log of x plus 3. And then here I see that I actually have 3 factors multiplied together. The 2, and then the x, and then the square root of x squared plus 1. And I'll actually even, so before I continue, just take a moment to recognize that this is actually the x squared plus 1 to the 1/2 power. All right, so I can go ahead and just go straight to writing this using, now remember that we use this division rule, but now natural log of m times n is natural log of m plus natural log of n, but I have 3 factors, so I'll just use another logarithm over here. So natural log of 2 plus natural log of x plus natural log of x squared plus 1 to the 1/2 power minus natural log of x plus 3. Do not get trapped into thinking that you can break this natural log up here. You can't, because the adding was done inside of the argument. All right, so keep that in mind, that that's a little bit different than when you were multiplying factors, right? You can't break up added factors inside of the argument, but you can break up factors that are like added terms, but you can't break up added terms, but you can break up factors that are multiplied together. All right, so now the last thing to do is what I mentioned before, that double check that you can't bring down any powers using the power rule for logarithms. And in this case, you can. You can bring this 1/2 in front. So you have natural log of 2 plus natural log of x plus 1/2 natural log of x squared plus 1 minus natural log of x plus 3. There you go. That is it for that example of expanding the natural logarithm. All right, let's try again. Here we have division again, but I'm going to go ahead and just change this into division. So this is a log base 2 of x squared minus 4 minus log base 2 of x plus 5. So this division, log base 2 of m over n, became log base 2 of m minus log base 2 of n. So using the division rule, or here the quotient rule for logarithms, I now have this, and then here I can factor x squared minus 4 into x plus 2, x minus 2. So I have log base 2 of x plus 2 times x minus 2 minus log base 2 of x plus 5. And now I see that there's even more to be done, because I have 2 factors that are multiplied together here. So I can split this up again using the product rule for logarithms. So this will end up being log base 2 of x plus 2 plus log base 2 of x minus 2 minus log base 2 of x plus 5. All right, what a time to be alive. All right, let's do another example here of using the logarithms to combine each expression. So we have, oh boy, natural log of x squared minus 25 minus 4 times the natural log of x plus 5. So remember how if I'm expanding the expression, I deal with the exponents first. So I'm actually going to deal with the exponents first and bring this. Now, you can bring up the 4 or the minus 4. It doesn't matter. But if I bring up minus 4, I have natural log of x squared minus 25 plus natural log of x plus 5 to the negative 4 power. And then I am going to use the the product rule for logarithms in reverse to write this as natural log of x squared minus 25 over, and this will be, now, it will be times, all right, times x plus 5 to the negative 4 power. But if you bring that negative 4 into the denominator, it will be x squared minus 25 over x plus 5 to the 4th power. All right, so this will be over 1. But now, let's see. Now you can factor in the numerator to get natural log of x plus 5 times x minus 5 all over x plus 5 to the 4th power. And then one of the x plus 5's can divide out. So you have natural log of x minus 5 over x plus 5 to the 3rd power. All right, so I hope that you enjoyed that here. So let me do one more example here. So again, if you have any questions, please feel free to ask. But here is another example of, oh boy, 2 log of 3x to the 3rd power minus 1/3 log of x to the 3rd power minus 2. So I'm going to deal with the exponents first. So I have a log of 3x to the 3rd squared plus log of x to the 3rd minus 2 to the negative 1/3 power. So just remember that I'm bringing the exponent up just like in the last example. And then I see that I have the adding here. So I'm going to use the product rule for logarithms to rewrite this as a single logarithm. So log of 3x to the 3rd squared times x cubed minus 2 to the negative 1/3 power. And then this can be brought to the denominator. So log of 3x cubed squared over x to the 3rd minus 2 to the positive 1/3 power. And you can go ahead and simplify this if you would like to. So then the 3x to the 3rd squared, 3 squared is 9, x to the 3rd squared is x to the 6th power, and then the 1/3 power is like the cube root, so you have cube root of x cubed minus 2. All right, so there it is as a single logarithm. All right, so the next couple of problems here are just using the change of base formula, which we did in the previous section. So just briefly, what you would do for the first one is just rewrite it as log 120 over log 6 so that you could use a calculator to figure this out. Or this one, log of 5.3 over log of pi so that you could use a calculator to figure it out. Or the third one, log square root of 5 over log square root of 2 so that you could use a calculator to figure it out. So the interesting thing is that you could also go ahead and graph logarithmic functions without using exponential form like we did in the last section by just say writing y equals log base 3 of x as log x over log 3. So then you can make an x and y table, and then you wouldn't have to plug in the y values. You could just substitute in x values, and if you pick 1, log of 1 over log of 3 is 0 over log 3, which is 0, and 3, log 3 over log 3 is 1, so you have a point at 1, 0, and a point at 3, 1, and there you go. There is your function. So, well, There you go. There you go. So now again, the asymptote is x equals 0. The domain is negative infinity to infinity. Sorry, 0 to infinity, and the range is going to be negative infinity to infinity. So there you go. So that is how you would graph this without changing this to exponential form. And of course, this whiteout is not very good, but it's a actually I thought that this was the higher quality whiteout, but anyway, 0 to infinity. Here we go, and now there we go, 0 to infinity. All right, so hopefully this all made some sense here, and that you got as much out of it as you could here. But that's really all I have for today. I really hope that you enjoyed this, but I am going to stop the recording now.